So in summary, if the reactants have a higher internal energy than the products, then delta E of the system is negative and energy flows out of the system into the surroundings. We already talked about how delta E would be negative because E final would be less than E initial. And the opposite is true. If the reactants have a lower internal energy than the products, delta E system is positive and energy flows into the system from the surroundings. So again, if you have delta E and it's a positive, then it's going to be E final is greater than E initial. Remember, initial and final are related to reactants and products. Products are your final destination and reactants are your initial. This is very important. There's a negative sign here, or it can go the other way around. Anytime you have delta E, the system, it has to equal the opposite in sign, but equal in magnitude of the energy of the surroundings. So you cannot have both positive. So again, this one means gained because it has a positive sign, although it's not shown, but this means lost. But the energy is equal. The energy is equal. That's why there's an equal sign. So there's a problem if we do this. And it's not a trick question or anything, but this is just to gauge your understanding. If we do this, that means that they're both gaining. This one gains and this one gains. Well, where does it come from? There has to be an exchange. So again, this one, you're indicating that you're violating the first law of thermodynamics, which means that the energy is coming out of nowhere. They're both gaining. Or if you have delta E of the system, negative equals delta E of the surroundings. Here you're saying they're both losing. We're losing to what? So keep that in mind. Now, while we're here, let's quickly talk about heat. So heat, as we discussed, is the exchange of thermal energy between the system and the surroundings. Remember, they have to have a temperature difference. So, but do not confuse temperature and heat. They are not the same thing. So temperature is used to determine the heat flow, whether it goes from the system to the surroundings, but they're not the same. So temperature is the measure of the thermal energy within the sample of matter. So for example, when particles are moving faster and faster, it means that they have a higher average kinetic energy, which means they have a higher temperature. But heat involves, again, exchange between the system and the surroundings. So you could say that you have two samples with two different temperatures. The exchange between them is the heat. So that brings us to, since we have different materials, that they can, of course, emit or absorb heat differently. And that brings us to something you must have covered in a previous chemistry class called specific heat. And specific heat is the amount of heat required to raise the temperature of 1 gram of a substance 1 degree Celsius. Each substance has a specific heat value that can be looked up or sometimes calculated. So I'll give you an example, and please make sure you understand this concept. So if I have two samples, if I have 1 gram of iron, and I have 1 gram of water, H2O. And I need to raise both, use different, by 1 degree. So this is one starts at 20 degrees Celsius and it needs to go to 21. So of course the difference is 1 degree Celsius. Same thing with water. You want to go from 120, to 21. So the difference is 1 degree Celsius. This could not happen by using the same amount of energy. So in order for you to do this for iron, you need to put in 0.45 joules of heat. And for water, this would be 4.184 joules. So look at the difference here is that they require different amounts of heat. In fact, this is why you cook with kitchenware that are made out of iron or metals, because they're good at absorbing heat. They don't take a lot of heat to increase their temperature. So you can try this at home, is you can put 2 frying pans, one with water, one with just empty, and you heat both. Of course, you know that the one without the water will increase in temperature much faster than the one with water. And it's simply because water has a very high specific heat, or requires a lot more heat, 9 times as much as iron, to increase by 1 degree Celsius. That's what it means. So this right here is called the amount of heat required to raise the temperature by 1 degree Celsius. That's specific heat. So for iron, it would be, for Fe, it would be 0.45 joules over grams Celsius. And for water, that would be 4.184 joules per grams Celsius. And specific heat uses the following equation. Q is heat equals M times C times delta T, or just MC delta T. M is the mass, C is specific heat, and delta T is the change in temperature. And the next example, the next video, I will explain more.